All right, kids, you made it back. Thanks for coming back. I hope I'm helping. Don't forget the Regents exams are up on NK Infinity as well. Right, this is practice test number 4. We're going to be doing 13 through 24 right now. Let's just get rocking and rolling. If you need to go to NK Infinity to find the rest of them, find them. They're there. Nice and organized. Let's start with this one. The results of workers between the ages of 26 and 45. Sadly, I'm not in that group anymore. That's just terrible. They are asked if they have at least 1 month's income set aside for emergencies. So less than 1 month's income, more than 1 month's income. So the first thing you got to do is figure out how many are in all these. I would always do these marginal frequencies. Just figure out what these marginal frequencies are. They're pretty easy to come up with. Let's see, that's 5, 145, that's 2, that's 142. 142 and 145 is 287. And then this is going to be 8 and 138, and this is going to be 9 and 149. Hopefully those add up to 287. Those are your marginal frequencies. Remember, joint frequencies, marginal frequencies, because they're out in the margins. They're your totals. So the question says, find the probability that both have, so you're selecting 2 people at random, and you want to know that both of them have more than one, at least 1 month's income. So there's 138 of the 287. So 138 out of 287 have 1 month income. That's the first person. The second person, and because it's an and, it's got to be 1 month and 1 month, right? So it's not an or, it's not an adding, it's a plus. So 138 over 287 plus or times 137 over 287. And you're going to multiply those two together, and when you do, I think you get, let me just go check. Let me just triple check. I don't know what that is. Actually, I do, but I'll come in later. Control division, 138 over 287 times control division, 137 divided by 287. There it is, 2.229, 23%. Yes! What is going on? Which graph is not a function? All right, so now I got to go. I think they're on the other page. That's weird. So remember, just simply for a not a function, they pass the vertical line test. See, it only hits it once. Doesn't hit it at all. Once. This is the one that's going to fail right here. This is the one that's not a function because it goes through those 2 points. It goes through those 2 points. If they were open circles, if these were open circles, like if that was an open circle and that was an open circle, this would be a function, but it's not because of that. The rest of them, oh, right here. See, open circles? See, it like goes through that circle, but it hits that one, right? The value of that to the nearest 10,000. So this is simply just a skill work. Do you know how to use the calculator? I'm not sure why I would ever put the one question like this on there, but who knows? Just in case, we'll go to tangent. Let me look at my paper here that's a much more organized format. Oh, so now we got to put it in degree modes, or degrees, minutes, and seconds. So we're going to come over here to this complicated button right here. Click on that. And do you see right here, this one right here? That is degree, minutes, and seconds. So that's the one we want. 126. So this is just basically testing, can you put stuff in your calculator, really? Press enter. Negative 1.3408. There it is. Negative 1.3408. Is it 408 or 407? So 4078. 78. So the 8 rounds that 7 up. So there it is. Careful with the rounding, I guess. Which one is now? So that one I know I got right. Don't have to look at it. The rounding. Just be careful with that one. Check that rounding. Highlight the rounding stuff. Check it. Yes. All right. So here's another one. You could just type into your calculator, get an answer. Type the answers in, and get an answer. But what's the fun in that? But by the way, when you do that, you star it and you're done. But what we're going to do is we're going to look at how to do this the right way. Now the problem is you're not allowed to have a radical in the denominator. So we're going to rationalize it by multiplying by radical 3 over radical 3. So in the denominator we just get 3 because radical 3 times radical 3 is the square root of 9. Square root of 9 is 3. Here we're going to distribute. So we get 3 square roots of 3 minus the square root of 24, because this times this is 24. Well, that's not one of the answers. So what they did was they broke this sucker up. They got 3 radical 3 over 3 minus the square root of 24 over 3. Now these cancel. How many of them just have square root of 3 up front? No, my guess is that's the answer. But where did this thing come from? Well, that one, you got to do a little bit of work. The square root of 24 is 4 times 6 all over 3. The square root of 4 is 2. So this becomes 2/3 square root of 6, which is that piece right there. And there's your answer. And again, type this in, get a decimal equivalent. Type this in, get a decimal equivalent. Although, quite honestly, they would act... Oh, no, this one doesn't work. No. And no. So, yep, it's definitely this one. All right, I was thinking this, if there might... That's definitely the right answer. I was just thinking they might have had 2 right answers. Jenna invests $25,000 to pay 4.75%. Now be careful with these things. Remember, that's really 0.0475. Don't make silly mistakes. Let's see. Got to figure out what the units are. Sometimes it really got to mess with you on the units. Is it time? Is it months? Is it years? What are we doing? Always looking for the rounding and round to the tens place. Good luck. Luckily for us, they're all round to the tens place, looks like. R is the rate. T is in years. All right, so we're investing $25,000. That's our initial investment. E to the 0.0475. Oh, my fours. 0.475. We're looking for T. What do we? Oh, we want our money to triple. So we want this to equal triple the money. Tripling my money is $75,000. All right, get the weird thing alone. Divide by 25,000. Ding 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 ding. That's just 3. That's what tripling means. Equals E to the 0.0475 T. Now, in order to solve a log or an exponential function, you must use logarithms. You have to. You have to use logarithms. So, natural log, because it's an E base, and it's all about that base. Now, the base would go down here, but with natural logs, you're not going to be able to put it in, but put it there, kind of get rid of it, make sure you know. Now, the E was with this, but now we're not. Now we're doing that. So, the natural log base E of 3, because logarithms are equal to exponents, is equal to 0.0475t. So you see how that log's equal to the exponent? Here's my exponent. And then I'm going to divide by 0.0475. So I'll go to my calculator. I go natural log of 3 divided by 0.0475. I hit enter. I get 23.1. 23.1. Now, another way to do this problem, quite frankly, is just to type in using this equation and just plug in your answer. So if I plugged in 23.1 for X, or in this case T, I guess. Oops, forgot something. And then I typed in my answer, 25,000, or my equation, times E to the 0.0475 T. Do I get about 75,000? That's really close to 75,000. If you pressed in the rest or plugged in the rest, you would get anything else close to that. I think I realized that the answer key for this one was not correct. So if you downloaded my answer key a little while ago, that you realize that I changed it, that for some reason had the wrong answer. I'm not sure if the little red circle moved on me or what, but whatever. So this was that viral video where that guy was, his kids walked in while he's on some big, huge interview with the BBC. Anyway, on the first day it was viewed 70,000 times, and then it increased by 60%. That is a ginormous increase. 60% increase. Ginormous. So find the cumulative number of views over the week. So this is that geometric sequence formula, series formula, excuse me, that does a summation. It's right here. So a sub 1 minus a sub 1 to the r to the n. So, oops, I can just go back. So it's s sub n is equal to a sub 1 minus a sub 1 times r to the n. I think it's n minus 1. I hate this formula. Oh, it's just n in this case. Oops. N all over 1 minus r. Now, the key is, and I don't think they put that in there. No, they don't put it in there. So the key is, and the tricky part is r. R is the tricky part. So 60,000 goes in first, minus 60,000. R is a 60% increase. So that is really 1 plus 0.6 to the n all over 1 minus 1 plus 0.6. Or you can just put 1.6. It doesn't really matter. But if you take that, you put it over in your calculator, control division, 70,000. That's embarrassing. 70,000 minus 70,000, parenthesis, 1.6, and it said for the first month, right? Or for the first week, raised to the 7th, over, I think there's another way to do this, 1 minus 1.6, enter. 3 million, blah, blah, blah. There it is. Now, I'm curious what would happen if I did this by recursion. If I did this by recursion and I said a sub 1 is equal to 70,000 and a sub n is equal to 1.6 times a sub n minus 1, and I just did that till 7. So let's see if that works. So we'll take 70,000 and we'll just press enter. And then we're going to do 1.6 times the answer. So that's day 2, day 3, day 4, day 5, day 6, day 7. Maybe that didn't work. All right, I'll have to figure it out. Anyway, there's the right answer. I'll have to figure out why that doesn't work. But not today. That was practice using that summation of geometric series formula. All right, here we go. We're off again. I don't know why. What's going on with this? But which one is cosine negative 1? So cosine negative 1, the inverse cosine function. Could be any one of these suckers. They all look funky. What in the heck's the difference between the two of them? I don't know. So what I really think you ought to do is take a look. Let's go back and look at the cosine function. Goes to this point here, which is 0, 1. Pi over 2. Pi. 3 pi over 2. And 2 pi. All right, so, and if you remember correctly, it's going to start here, it's going to end here, it's going to have this here. So the reason I'm doing this is because this is the point 0, 1. This is the point pi over 2, comma 0. This is the point pi negative 1, 3 pi over 2, 0, and 2 pi, comma 1. Now, why am I doing that? Well, because the inverse is just these things backwards. So instead of 1, 0, I need to find, instead of 0, 1, I need to find one that goes through 1, 0. There's only one of these that goes through 1, 0. It's choice 3. Only one of them. Remember, inverses are just taking these things and switching x and y. Does it also go through 0, comma pi over 2? Oh, look, 0, comma pi over 2. Does it also go through negative 1 pi? Oh, let's look. Negative 1 pi. Does it also go through 0, 3 pi over 2? 0, 3 pi over 2. How about 1, 2 pi? 1, 2 pi. There's your inverse. Switch x and y. That's what you need to be thinking about, okay? All right. Again, on this question, you probably just want to stow the answers and check them. We're going to do it the right way. We get the weird thing alone. I'll be right back. All right. So I was saying I don't like to go over 5 minutes because my voice, I like this, and it's really awful, and I hate when you guys have to suffer through that. Square both sides. Square and a square root, they say goodbye to each other. See ya. Adios, amigos. This one I'm just going to write twice and double distribute, right? So we're going to double distribute that thing. X squared plus 4x plus 4. Everything goes to that side. 0 is equal to x squared plus x minus 12. So if you bring those two things over, that's what you get. X plus 4, x minus 3. And your two answers are x equals negative 4 and x equals 3. Now, I should have known that because they're all sitting right there. However, there's a really good chance one of them does not work. So let me plug in 3. If I plug in 3, I get 9 plus 16. That's the square root of 25, which is 5. And the other side would be 3 plus 2. So it looks like 3 works. So that's definitely out, and that's definitely out. Now I just got to check to see if negative 4 works. And if you try negative 4 on your calculator, I would just definitely do this on your calculator. I don't know why I was doing it on paper. Negative 4. I mean, when you're going to find out this one doesn't work because you'll see. Negative 4, control var x. Type in the left side. Now, when you type in the left side, you end up with a square root of negative 3 times. No, it's not negative 3. It's 3x. 3x plus 16. Now, that's really 4, which is the square root of 4, which is just 2. But if I plug in the other side, and I just put it, what is it, x plus 2? This is going to be negative 2, and that's not going to work. So the answer is choice 3. Star it. You can check that one. Don't have to look at it again. A car traveling on a straight road for, looks like 24 seconds. The car's velocity, v of t, is measured in seconds. So really, it's just a piecewise function that we got to create this piecewise function. So let's look at this first piece. This first piece has a slope of up 20. So it's a linear function. So it's y equals up 20 over, so it's up 20 and over 4. 20 over 4 t. I guess that's it. So that would be just 5t, right? So I'm looking for the first piece, 5t, but that's from 0 to 4. 5t from 0 to 4. Well, that sucks. They're all 5t, 0 to 4. All right. Now let's take a look at the second piece. Well, the second piece is just a horizontal line right here. A horizontal line is like, that's the line y equals 20. So I'm looking now for the one that's got y equals 20 from 4 to 16. And it looks like this is the big winner, because I don't even see any others that have 20. So let's try, let's make sure. We're going down 20 and over 8. Negative 20 over 8 is equal to negative 5 halves. And let's see, we have negative 5 halves. And my guess, we do have a problem though. All right, so she said this was the right answer. We got an issue because that y-intercept is no way that y-intercept is right. This is the right answer, but there's no way that y-intercept is right, right? That y-intercept, so I'm going to change that. Maybe, hopefully you have the corrected version. The y-intercept is way up here at positive 60. So while that is, in fact, the right answer, this should be positive 60. So I'm going to have to go fix that. Sorry. Weird. Let's say it's the most right answer. All right, we're going to do this by completing the square. This is my first step. Bring the constant over. So you get x squared plus 7x plus square equals 11 plus square. So what are we going to add to both sides? Well, if you remember correctly, for completing the square, you want to take half of this. So that would be x plus 7 over 2, and square it to get this. Well, if you square 7 over 2, you get 49/4. There it is, kids. That's the answer. 2 left. The number of minutes took the quiz is summarized by this below. If the mean number was 17, so we want this to equal 17, so that's all the same, which equation could be used to calculate the value of x? So one of the juvenile minds will say, oh, let's just add all these up. Well, if you add all these up, you get 119. But, sorry kids, those are not the right answers. So what you need to do is you need to add up 5 14s, that's 70. 3 15s, that's 45. We don't know what that is. 5 of those, what is that? 85? 36? 190 and 20? My guess is when you add those up, you get 446. So if I add all those up, I get 446, plus I want to add these up. Well, there's 16 of these x's. Well, that's plus 16x. All over. Now I got to add these denominators. My guess is the denominators add up to 26. Let's see. 5, 8, 13, 15, 25, 26. 26 plus this one. And there's your answer. Choice 4. This problem always freaks kids out. What is the radian measures of the smaller angle formed by the hands at 7 o'clock? First of all, the reason it freaks out most kids is because here's your clock, right? Looks like a smartphone with a little button down here, right? And it's got some like, it's 7 o'clock. What are you talking about angles on a clock? It says 7 o'clock on my iPhone. Yeah, you need to know how to use a regular clock for this problem. 7 o'clock. Big hand formed at here. Little hand formed at the 7. Now remember, it's broken up into 5-minute groups, right? So I need to figure out this angle measure right here. I'm going to figure it out in degrees first. I'll tell you why it really doesn't matter. Degrees is actually much harder to do by degrees, but what the heck. So that is 1, 2, 3, 4, 5. 5/12 of 360 degrees is the smaller angle. So if you do that, you get 150 degrees. If you just multiply that, you get 150 degrees. So now I'm going to change 150 into radians by multiplying by pi over 180. Now, how did I get this 5/12? Well, there are 12 of these things on the clock. I assume you know that, right? And 5 of them are make up. I got 1, 2, 3, 4, 5. 5 of them get me here. Anyway, if I multiply this out, what I end up with is, well, notice my pi's in my answer. So really what I just want to do is simplify 150 over 180. That's 5/6. But if you just want to, 150 divided by 180. I hope it doesn't give me the exact. I hope let's just simplify. Ow. This is that silly. That's the one thing I don't like about this calculator. Like, it doesn't read my mind. Escape. So if I go to auto, that is 5/6. So that is 5 pi over 6. Now, how would I do that an easier way? Well, an easier way is just to work straight with radians anyway. This is, if I go straight down, that's 6 pi over 6. Right? This angle here, from here to here, is 6 pi over 6. Well, I'm only going from here to here. Well, that's 5 pi over 6. And that's the fastest way to go through that problem. All right, kids, that ends the multiple choice. I certainly hope you enjoyed yourself. Please hit the subscribe button. Get you on the flip.